What I'd like to do in this video is take a look at page 245, numbers 47 through 51. And those problems ask us to determine or decide whether the graphs of the two equations are parallel and explain your answer. So we'll take a look at number 47. And now we have to remember that parallel lines have the same slope. So if we're looking at parallel lines, we basically just have to determine if the lines have the same slope. And we know from our slope-intercept form, y equals mx plus b, that the coefficient of x, in this case m, that is the slope. So the easiest way to determine if two lines have the same slope based on their graphs is by looking at their equations, putting them in slope-intercept form, and then seeing if m is the same, if the coefficient of x is the same. If they are, then they are parallel. So we take a look at these two equations here, and right away we notice that they're already solved for y. So just like the last video we spoke about, that this is some sort of disguised y equals mx plus b. Okay, we can have y equals mx plus b. We can have y equals b plus mx. It's the same thing, commutative property. We could also have mx plus b equals y, or b plus mx equals y. All those are the same thing. This y equals mx plus b could show up in 4 different forms. So if I take a look at this, this is one of those y equals mx plus b forms. Y equals 2x minus 12. I can rewrite it. Now I have it in slope-intercept form, and I identified here that the slope equals 2. M equals 2, or the slope is 2 over 1. Now the same thing here. This is also another disguised form. Instead of y equals 10 plus 2x, we'll call it y equals 2x plus 10. And once again, m equals 2. So, yes, they have the same slope. Yes, they have the same slope. Therefore, they are parallel. That's my explanation. They are parallel because they have the same slope. And number 47 was fairly easy to find out. If we take a look at number 49, the equations are a little bit different. They're not in slope-intercept form now. So I have to put them in slope-intercept form. Again, I have to get them to look like y equals mx plus b. So I do that in the first equation by adding 4x to both sides. And I have 3y equals 4x plus 3. And then I divide by 3 on both sides. Y equals 4x over 3 is just 4/3 x. Positive 3 over positive 3, that's a positive 1. Now here I've identified that my slope is 4/3. I'll do the same thing to the other equation. This one is one step ahead, so all I have to do here is just divide by 3 on both sides. And I get y equals negative 4x over 3 is negative 4/3 x. Positive 9 over 3 is a positive 3. And here, my m is equal to negative 4/3. Well, I know that 4/3 does not equal negative 4/3. So the lines are not parallel here. Lines are not parallel. Because the slopes are not the same. So I take a look at this equation. They look similar, 4/3 and negative 4/3, but we know that on a graph, if we were to draw a quick graph, one of these lines goes like this. The other one is a negative slope. The other one is a negative slope, so it's got to go down. Obviously, these lines are not parallel. One of them has a positive slope, the other has a negative slope. So obviously, they are not parallel. Finally, number 51. Number 51, and again, like in the other examples, I want this to look like y equals mx plus b. Okay, this first equation here, it's a little jumbled up. Again, I want y by itself so I can move everything to the right hand side. I'm going to add x and subtract 3. Okay, I'm actually going to do 2 steps in one here. So I'm left with y equals, if I add x, I get 3x. If I subtract 3, I get 0. So it's really plus 0. Or I can just write this equation as y equals 3x. And we spoke about this type of equation in the last video. Plus 0 means here that this y-intercept is 0, 0, goes through the origin. Again, m equals 3. My slope is 3 over 1. Now I move on to this equation. I'm going to subtract 4 from both sides, and I'm left with y equals 3x minus 4. And I find that m equals 3. Both slopes are the same, so I can confidently say that the lines are parallel. And my explanation is because the slopes are equal, or they're the same. Slopes are the same or they're equal, so it makes the lines of these two equations parallel.